So I wanted to help explain my thought process on ContestD because it seemed pretty confusing. So I made a pretty picture, and hopefully you guys can follow along and this will help you. So if you didn't read the prompt for it, what we're supposed to do is, here's a sample here. We're supposed to take in a number, which will be the number of strings that will follow. We will search the string and check if it's a palindrome. And if it is a palindrome, we will return with the word palindrome. If not, just reverse it normally. And so the way I chose to attack this, because there's different ways that you can do this, was I said, I think I should have 4 strings. Well, no, first I should start with a string in, and after that I will reverse it, and then I will make another string that will hold that. So it will have the reverse of string in, and then with that, not with that, but I'll with string in, I'll take out the punctuation and spaces, and then I will convert everything to caps, and then I will use string up to hold that. So at this point I have string in, string reverse rev, and then I have string up. And then I will reverse this capitalized string to have string rev up. And then using those 2 strings, I'll compare them and then see if it's a palindrome or not. And then I'll return palindrome, or just, if it does end up being a palindrome, I'll just return whatever this was, string rev. And so here in my code, that's exactly what I do. This first part is just a basic starting importing the scanner, which we need to get our first string. Public class, static void main. This is declaring the scanner, creating the scanner. And then we get here to my num lines, which I made a variable for. I said I will take the next int that comes in. So if you look at the example, I will take in 3. So 3 is now my num lines. But the problem with that is, Gusty explained too, that next int doesn't take up this whole line, that there's a secret /n hiding after the 3, and we can't do anything until we clear that. So that's exactly what we do. We use this line in the next line to get rid of that. Well, not get rid of it, just get past it. Which basically says read it and do nothing with it. So we read the /n, we did nothing with it, and now we're going to go to my for loop here, and this for loop, its job is to move the string along to the next string. So here I initialized it. I said int h equals 1, and then as long as it is less than 3, because we said num lines was 3, so if it's less than 3, go forward. So all that does is it just shifts it down until the end. And so while it's on a specific line, and now it's on line 1. So this is where string in comes in. We'll take string in and we'll will read it, will assign it, and then I initialize my other 4, and I'm using string buffers for my reversed up and my reversed, just because string buffers are different. It was in the curriculum, it was on the website, that I didn't know what they were until I saw them there. That they're basically strings that were meant to be manipulated with, so they have built-in methods already. So I decided to take advantage of that and have string buffers in for those. I didn't make the other ones string buffers because I needed to do things to them that a string buffer could not do. I'll try to explain that later, but so I made string in a string, string up a string, and then I have string rev up and string rev as buffers, and these I made blank, so just initializing them, just saying that they exist, but we don't have anything yet. So here we initialize my next step in the plan. Here the pink step is to reverse string in. So this is one of the methods that a string buffer can use, append. Append just adds onto the string whatever you want. So string rev is this one. No, that one. Says add onto string rev string in. And then after that, here is another method you can use with a buffer, is reverse. So basically all I did was I put string in, I put it into string rev, and then I reversed it, which is exactly what we wanted. We just wanted it reversed. And now onto the orange step here. This step, we want to take out any punctuation, any spaces, and convert everything to uppercase. And then assign that to string up. So here is where I start building string up. So inside this for loop, the first for loop, I made another for loop that will move along each letter. So instead of moving along each string, instead of going down, it will go across. So it will go to H-E-L-L, blah, blah, blah. And I wanted to mention, in case you didn't know, the reason why it's -1, string.length -1, because dot length, here I made a picture, dot length returns the number of characters. So here in hello there, it would return 12, because there's 12 characters. And then, but position starts at 0. So H is 0, and then it goes up to 11, where the exclamation point is. And so we can't just make it dot length, because when it reaches dot length, which is 12, it won't, there's no position 12. It only goes up to position 11. So it'll reach that and it'll throw out of bounds. So it'll go to 11 and it'll try to go to 12, but it'll say, oh, I don't know where to go, out of bounds. So that's why it's -1, string.length, which is 12, -1, which is 11, which is the last position there is. So that's why that is. Just to be safe, I throw in that command, trim, which all it does is if there's a space in front of it, or like any spaces, like there's spaces in front or spaces at the end, all it does is just X's them out and just starts at the first actual character. I didn't know what the test cases would be, so I just wanted to be safe. So that takes out excess spaces at the ends. And now here I have my first if. So this was the hardest part for me to conceptualize. But what I ended up getting was I ended up checking if there was not. So there's the exclamation point there. That's the not operator. So if there is not at the current position, which is what this means, substring at I plus 1. So at the current character that we're at, if there is not an exclamation point, move on to the next one. So if there isn't one, it skips down to the next one, and this is where we check for another one. So if there is not a period, go on to the next one. This is the little tick mark. So if there's not a tick mark, go on to the next one. This is, I think, a space. So if there is not a space, go on to the next one. This one is question mark. So if at the current character there is not a question mark, go on to the next one, and so on and so forth. If there is not a dash, if there is not a colon, if there is not a semicolon, and here for quote was different because you had to do / quote, because Java automatically thinks you're trying to do something with quote. So if you want to just say a string quote, you have to do / quote. So it's a little syntax and that might mess you up. So here it just says if there's not a quote, move on to the next one. And then finally, if all of these are met, so if the character that we're at is definitely not one of these, then we'll assign it to string up. So it says here plus equals, because remember at this point our string up is nothing. It is zilch. It has nothing in it. So what we're doing is building up character by character. So here we check H, for instance, because we start I at 0. Here I is 0. So at 0 we check, is it a exclamation point, is it a period, is it a question mark, is it a comma, is it a blah 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 blah. If it's none of those things, then we will add it to string up. So string up is now H, has H in it. I hope but to upper. So it assigns it and then uppercases it. H is already uppercase, so nothing changes to it. So now, after that, loops back up to the top, and then we do it all over again. Except now we can move on to the next one. So I is now 1. Is it a exclamation point? Is it a period? Is it a question mark? Blah blah blah. If it's none of those things, then add it to string up. So up is now equal to H, and now it's going to turn into a capital E. God, this sucks. Capital E. And then it'll go on to the next ones. And for instance, when it reaches 5, there's a space. So one of these catches that. So I think it was that one. So it says if there is not a space, but there is a space, so then it automatically skips. Oh no, it doesn't keep following this little pattern. It wasn't true for that, so it gets kicked out. And then there's nothing else outside all these ifs. So all it does is, okay, well, nothing's down here, so I'll go back up So then it basically just kicks it out and restarts it. Then now moves on to 6 and goes further. And then when it reaches 11, it finds an exclamation point. Here, this ends up not being true, so it kicks it out. And then it goes back to the top. But at this point, 11, it equals 11. So it so 11 was the last character it could actually be, so it had to be less than or equal to. So as soon as it hits 11, this ends, and it gets kicked out to the next step, which is the blue. So now, theoretically, we have our string up. Okay, I don't need to draw it here. At this point, string up is now hello there. No spaces, no exclamation points, no nothing. So now step blue. Oh, and also don't all these ifs. I made sure I had the right amount of brackets. That might mess you up too. That's why I have a bunch here for each if. Step blue. I build up my reverse. So all I do is I take my up, and just like I did with these two here, I just took this and I reversed it. Because reverse up, remember, I made a buffer. So with the buffer, we can use .append, which adds it, and then we reverse it. So basically just took it, we added it here, which this was nothing, and then we reversed it. And now on to step green, here, green, is where we compare. So I have an if-else statement. So if string up equals, and since rev up was a buffer, it's not going to be equal. It's not the same as a string. So string buffers have a method called toString that basically just changes it into a string. So that's what I did here. So if string up dot equals the string version of string rev up, then palindrome. If not, return string rev, which we declared way before here. We declared it and we kept it safe so that we could call it again if we needed to. And after that, after it prints out, after it's done with everything, boom, circles all the way, because this is just in a big for loop. Circles back here. So now h is no longer 1, h goes to 2. So what's 2? 2 is this next line. So it does all that all over again until it reaches the bottom. And then, whoops, I didn't even do that. Circles back up, and then goes back for the last line.